In today's video, we will be covering the first of several lessons on analytic geometry and trigonometry. This will support the fundamental engineering review, and today's topic will specifically be focused on straight lines. So a straight line in two-dimensional space is shown here. The slope of the line is m, the y-intercept is b, and the x-intercept is a. A known point on the line is represented as x1, y1, and another point shown here could be x2, y2. So there's a few formulas we'll be covering. So the first is a slope, where that is the variable m, as I previously mentioned, and to calculate that, if you're given 2 points like x1, y1 and x2, y2, you can calculate it as shown. So here, if you're given these 2 points, that will allow you to determine the slopes of the two lines are equal or parallel. Next, we're going to calculate if the slopes of the lines are perpendicular. And that formula is shown here, where if you know one slope, the perpendicular line to that line would be m1 equaling the negative inverse of that other slope. Now let's cover a few other equations of lines. So starting off with the standard form of the equation of a line, which is y equals mx plus b. So the equation of a line can be represented in several forms. The procedure for finding the equation depends on the form chosen to represent the line. In general, the procedure involves substituting one or more known points on the line into the equation in order to determine the constants. So this equation is the standard form of the equation of a line. This is known as the slope-intercept form because the constants in the equation are the line slope m and its y-intercept b. So next we'll do the general form of the equation of a line, which is ax plus by plus c equaling 0. And then following that, we'll do the point slope form. So this is an equation of the line. So this equation defines the lines in terms of its slope m and one known point x1, y1. The last formula we'll be covering is the angle between two lines, which is the alpha equaling the tan inverse or arctan, and you would need to know the two slopes m2 and m1 to determine what the alpha or the angle between the two lines is, as shown on the schematic on the right. So before we finish up this quick little crash course on straight lines, let's go through an example. So a line goes through the points 4 and negative 6 and is perpendicular to the line y equals 4x plus 10. And we're asked to find what the equation of the line is. So for starters, let's write out the standard form, which is y equals mx plus b. Following that, we'll also write down the slope of perpendicular lines and what that needs to be. And that is m1 equaling negative 1 over m2. So with us being told that it's perpendicular to the line y equals 4x plus 10, the slope of that formula y equals 4x plus 10 is 4. So with m2 being assigned the value 4, we can determine what m1 is, which is negative 1 over 4. So next, we're going to transition that standard form equation and use the point 4, negative 6 that was given in the formula as well. And we're going to substitute all those values into the standard form. And this will allow us to calculate what the y-intercept is for the line with the slope negative 1 over 4. So with us knowing what m is, as well as the point in which both lines go through, we can then calculate what b is. And b is the y-intercept of this line. So from this formula, we're able to calculate that b is negative 5. So now that we know what the slope and the y-intercept is for this perpendicular line, we can substitute that in and reformat our own standard form equation of the line. So the equation of the line that is perpendicular to y equals 4x plus 10 is y equals negative 1 over 4x minus 5. And that is our answer. let's go through another example before we finish up this crash course. So the angle between the line y equals -7 plus 12 and the line y equals 3x is most nearly what? So let's pull that angle between two lines formula, which is alpha equals tan inverse of the slope 2 minus slope 1 over 1 plus slope 2 times slope 1. So from that, we just need to assign equation 1 and 2 so we can assign the values of the m1 and m2. And it could be either order, it just matters that you're consistent. So for this instance, I'm going to assign equation 1 to be y equals -7x plus 12 and equation 2 to be y equals 3x. From that, I'm going to assign m1 to be -7 and then m2 to be 3. With that, I can then substitute those values into the angle between two lines formula, and then I will simplify that out to get an alpha equals tan inverse of 0.5. And if you convert that into degrees, you get approximately 27 degrees, which is our answer for this example. So I hope you guys enjoyed this video and got gained some knowledge as well. And stay tuned for the next video where we will be covering polynomial functions. Hope to see you guys there. Make sure to like and subscribe if you found this video helpful. Thank you.